So let's start with the gravitation chapter. So the first topic is Newton's law of gravitation. Now here what Newton's law of gravitation is, it states that every body in this universe attracts every other object with a force which is directly proportional to the product of their masses. That means the force is actually directly proportional to the product of masses. That means F is directly proportional to m1 dot m2. Now the second thing, it states that force is inversely proportional to the square of the distance. So F is directly proportional to 1 over r square. The distance here is r, so 1 over r square. Now I can write F as F directly proportional to m1, m2, r square. And when we remove this proportionality sign, we get a constant, that is G, universal gravitational constant. So G m1 m2 over r square. Now this is the preface knowledge of you. Now we need to write it in vector form. So let's start with it. So first of all, I would be defining, as you can see, we have a F12 force here. So I would be defining F12 first in vector quantity. So I would be taking G m1 m2, and we have a unit vector here, that is r21, and unit vector is actually r21 here, which describes from A to B. It is a unit vector from A to B. Now it is written here and r square here. Now r21, a unit vector can be defined as r21 vector over r unit vector. So I will replace r21 unit vector with this. So it will be G m1 m2 r square and r21 vector. This will be r cube now. And we have a negative sign here. So here negative sign indicates that the direction of F12 is opposite to that of R21 unit vector. Now I would be writing F21. So F21 can be written as minus G m1 m2 over r square, and r12 cap, and r12 cap can be again replaced. So G m1 m2 r12 cap, sorry, not cap, it will be a vector quantity now, and at denominator we have r cube. Or we can write this equation as positive G m1 m2 r square r21 cap, because we have r12 cap equal to minus r21 cap. Therefore we can write like this. Now it is very much clear that F12 vector is equal to minus of F21 vector quantity. That represents Newton's third law of motion. Now a special condition is there. If suppose that we have same masses, m1 is equal to m2 and r is equal to 1 and g is, then g will be equal to f. So in this condition, the universal gravitational constant is equal to the force of attraction between two bodies, each of unit mass, whose centers are placed unit distance apart. So that's the definition of that. Now the G value is given as 6.673 into 10 raised to power minus 11 Newton, and G value does not depend upon the nature and size of the bodies. It is same throughout. That's the end for the first part, Newton's law of gravitation.